In two other videos, I'm going to talk about using a map to determine the distance and azimuth between 2 points on a map, and also how to find the location on a map given the distance and azimuth from a known location. But the first thing that you have to know how to do is how to orient your map correctly in the field. Right here I'm showing you all a map that's very simple, and typically you'd be using some kind of USGS topographic map or something a little bit more fancy than this, but this will do for now. And notice that I've laid a grid over here, and that's to help you work with your compass. I have a couple points that I have marked, A, B, C, and D. Down here in the lower corner, you can see that I have a scale bar, and I also have a north arrow. What you can see is that this north arrow, you want to have in real life pointed towards true north. The problem is if I take my compass and I place it onto my map that I have here, and then I'm going to dial this in to true north, adjusting for the declination, so keeping in mind that I should actually, instead of having it right on north, like this, I should have it about 2, a little bit over 2 degrees added to north. So if you think of 0 and then you add 2 point something degrees, then that's going to be where you actually want this to adjust for the declination that I've talked about in another video. So now that I have this, what you can see here is that if our goal, if we want the compass pointing in a certain direction, is for this red floating needle to be in its home, which is in this orientation arrow within the dial here, then we need to turn the entire map to make this so the map is actually having its north pointing towards true north. So I'm going to turn it, and I think it's easiest to line it up on the edge. I like this. It makes it easy to think about. And then what we're going to find here is that this is about the best orientation. I think I'll turn it a little bit, so I angle it a little bit. I just did this in the video, not turning my body. Typically you'd be holding the map in your hand or on your lap, and you would turn your body to do this. I just flipped the map and the compass, right, to show you all here in this kind of setting. But keep in mind that you could actually turn your body with the map so you're facing true north. So in another video, I taught you how to orient your map so it's facing in due north direction, which is important if you're going to be trying to pull an azimuth between two different locations on the map. You have to have your map facing towards that true north. Next, what I'm going to show you how to do is to determine the distance between two different points on at least this simple map. Keep in mind that if you were using a topographic map, there would be different methods that you could use. This is pretty simple what we're going to do here. So one thing to keep in mind is if you're determining two distance between points on a map, you don't really need to have your map oriented towards true north. But I'm going to keep it this way for simplicity. So what you want to do is either with a ruler, or your compass has a ruler on it in inches and centimeters. And you can take that, there's a scale bar over here that you can see that's 100 meters. You would come over here, you'd lay your ruler onto the scale bar, mark here, which is 5 centimeters, okay, come over, measure again. I'm going to estimate, even though it's kind of in between. For the sake of simplicity, I'm going to say that it's approximately 5.2 centimeters per 100 meters. This is going to be our conversion factor to figure out distances from the map to distances on the ground. So the next step in this process is that you would want to take your compass and you would want to go get the distance between 2 points that you're interested in. In this case, I'm going to show you the example of A to B. So you would want to center your 0 onto the first point, and then you would want to kind of center it on A as well. So if you look here, it's about 3.7 centimeters. So we know we have 3.7 centimeters from A to B. Okay? So the next step here is to take and use your conversion factor to convert this to the number of meters on the ground. So what we would do here is we take 100 meters to 5.2 centimeters equals 3.7 centimeters. So this is the distance from A to B on the map over X meters on the ground. 3.7 divided by 5.2 is approximately 0.7115. Then you multiply that by 100, and you would end up with 71.15 meters between those two locations. If you know your paces and what that converts to in regards to meters, which you will know, then you can use the video that I'm going to provide on taking meters and converting it to your paces, and you would actually be able to, with a known azimuth, walk between these 2 points. And later on I'm going to talk about, well, how do we figure out from a map what the azimuth is between these 2 points or other points on the map. So in this video we're going to talk about how to find an azimuth between 2 points on a map using your compass. So one thing to keep in mind is that I have already oriented this map so that it's pointing true north, and that was using the compass, and I've already provided a video on how to do that. Let's say that we want to figure out the azimuth between point A and point B. What we want to do is we want to take the compass and we want to line it up between those 2 points so that this edge along here connects those 2 points. Whichever way we want to travel, right? So in this case, we want to travel from point B to point A. So we want this line of direction to be facing from point B to point A. So then what we want to do is we want to get it so we ignore the floating needle, and we want to make it so this orientation arrow back here is pointing true north, which in this case is this way. So we're going to get it so that these orientation lines back here, see these red orientation lines? We want them to be parallel to the grid north-south lines that are on the map. So in this case, what we're going to see is that we have about 308 degrees. That's the azimuth from point B to point A. But what if we want to know the azimuth from point A to point B? There's some simple math that we could use to do this, but I want to show you how to use the compass to do this. So in this case, we're interested in going from point A to point B. So we're going to put the compass edge between point A and point B. We're going to make sure that this line of travel is facing from point A to point B. And you can see that I need to turn this such that the arrow is now pointing north again. And those orientation lines here, those red lines in the back, are pointing north-south and align with the grid lines on the actual map. So you can see here it's about 128 degrees. What you should notice from this is that the reason why I said that you could do some simple math is because this is called a back bearing. So 308 degrees, which we got B to A, minus 180 degrees equals 128 degrees, which we just got has the back bearing from A to B. So that's another approach that you can take to do this. But this is showing you on a map how to use your compass to determine those azimuths between 2 points. And you can do that between any of these points on the map. So now let's say that you are given a location on a map and told to go to another location on the map, but only given an azimuth and a distance from that known location. What do you do then? So let's say that you're told to go 50 meters from point B at 200 degrees, and you're told that 200 degrees was given to you as a compass azimuth. So that means that it came from a compass. So you need to convert that and deal with the declination going from compass to map. Since we know that we're going from compass to map, we know that we want to add the declination. So here our declination is about negative 2.87. So we want to add that to the 200, which means we're really subtracting. So I'm going to go on here, I'm going to dial in, and I'm going to dial this in. It would be 200 if it was a map azimuth that you were given, so, but it's not. It's going to be from a compass. So we're going to subtract from there nearly 3 degrees to deal with that being a compass azimuth that you were given. Okay, so that's dealing with the declination, and you just have to kind of learn those rules. So the next thing that you're going to do here to figure out where you're going, at least the direction that you're going, we'll deal with the distance later, is you're going to take your compass, you're going to take this little center part of the dial, you're going to put it over the B, center that over that B dot, not the actual B itself, but the dot that associates with the known location. And then you're going to turn this compass until, kind of similar to before, your north arrow behind here, and that orientation arrow is facing north, and your lines, I'm a little bit off, so I'm going to turn a little bit more. Your lines are parallel with the north-south lines that are on your map. So from there, what I know is, because this is the direction of arrow travel, I'm going to put a line, a little dot down here, okay? And that's going to be 200 degrees from a compass towards another unknown location, okay? So we're going from B to that unknown location. We can use the straight edge of our compass and we can draw a line, okay? And since you know that you want to go this way, oftentimes what people do is they'll draw an arrow that way to indicate that that's the direction that we're going. From here, the next step to figure out is where is the point relative to the distance from B. We already know the direction from B, now we need to get at the distance. Note that my line's a little bit off from the center of B. You would want to be a little bit more careful. That's because I'm hovering over a desk right now to do this. You would want it to be more centered on that B dot, but we'll work with it as it is right now. So earlier on, we figured out in another video that our conversion factor on this particular map is 5.2 centimeters per 100 meters on the ground. So now what we want to figure out is, if we were given that we want to go 50 meters, how many centimeters on the map would this be? So I'm going to use this conversion factor, and what we're going to do is equals 50 meters is how far we want to go over X centimeters. 50 divided by 100 is 0.5, multiply that by 5.2, and you get 2.6 centimeters is the distance from point B that you should go using this scale bar. So I'm going to take my compass, turn it around, make it a little bit easier, go from about the center point of B, line it up with the line I've already made in regards to the direction of travel. I'm going to get 2.6, which would be right about here. And now, this is our unknown location, okay? And you can do that with any information that you're given, as long as you're given a known location and you're giving an azimuth and a distance.